Good morning. My name is Deepa Shokshatoji from MSc in Cloud Computing. Today I will be presenting my research proposal titled Understanding the Impact of Optimized Resource Allocation in Cloud Computing for Improved Cost and Performance. This proposal explores how intelligent allocation strategies can improve efficiency, reduce costs, and handle the growing demands on cloud systems. Here is the quick agenda where first I'll provide the introduction and motivation behind this research. Then I'll outline the problem statement and research question. After that, I'll present a brief literature review followed by the proposed methodology. Finally, I'll wrap up with the conclusion. Coming up with the slide 3, introduction and the motivation. Cloud computing continues to evolve rapidly, becoming a central to digital services across industries. So, however, we all know that allocating resources in the cloud remains a major challenge. Often, resources can either over provisioned, leading to wastage and unnecessary cost, or under provisioned, which results in a poor performance and service degradation. What's needed are intelligent, adaptive resource allocation strategies that can respond to dynamic workloads. The goal of this research is to find a ways to boost performance, reduce expenses, and enhance the overall system efficiency. Coming up with the slide 4, where it addresses the problem statement and a research question. The key problem addresses in this study is that the cloud resource allocation is still mostly reactive or static, meaning decisions are based on a fixed rules or a past behavior without a real-time adaptability. So this leads to poor resource utilization, higher operational cost, and limited scalability. The research question is, how do optimized resource allocation strategies affect cost efficiency and performance result in cloud computing environment? In other words, we can even make smarter decisions that can improve both cost and performance at once. Coming up with the first slide, fifth, which explains about the literature review. In reviewing existing literature, I examined both heuristic based and machine learning based resource allocation strategies. Among the model studies are LSTM, XGBoost, and Random Forest, each offering a different strength in predicting and scalability. Metrics used in prior workload include CPU utilization, memory usage, latency, and energy consumption. However, significant gaps still exist, such as there is a limited support for real-time decision making. Many approaches lack scalability across a varied environmental, and there is an incomplete integration of cost and performance objectives. These gaps highlights the need for more robust intelligent solution. So coming with this sixth slide, where it addresses about the proposed methodology. In proposal focuses on developing and predictive resources allocation framework using a machine learning. The data set I plan to use is from Kaggle, which contains a performance metrics of a cloud workloads. The goal is to model workload patterns and use that to forecast a future resource demands. Specifically, I plan to test a 3 ML models: Random Forest, which is known for interpretability and strong performance; XGBoost, which offers a high accuracy but may require more resources; and LSTM, which can capture long-term temporal patterns in a workload behavior. These models will be evaluated using a metrics such as accuracy, F1 square, latency, and energy consumption. The key aim here is to assess whether predictive allocation is feasible and practical in a real world cloud environment. So, wrapping up with the conclusion, here I like to conclude that the study recognizes the urgent need for more intelligent, adaptable resources management in cloud computing. Traditional methods are no longer sufficient in the face of modern, which we already know, like a dynamic workloads. So, by applying a machine learning models like Random Forest, XGBoost, and LSTM, I aim to demonstrate how predictive strategies can lead to such as better energy efficiency, lower operational cost, and improve performance across cloud systems. While this is still a proposal, it leads to a foundation for a future implementation and validation through simulation or real-time developments. Thank you so much for your time and attention. I look forward for your feedback or any questions you might have about this proposed research. Thank you so much.